Have you ever walked into a boiler room and seen bare steam pipes? Maybe the insulation was removed years ago when asbestos was abated. Someone took it off to repair a leak and never put it back on. Most people just simply shrug and say, "What? It makes the boiler room warmer." Like it's no big deal. Actually, it's one of the biggest misconceptions in steam heating. Removing pipe insulation doesn't just waste heat, it changes the way the entire system operates. It increases fuel costs, increases boiler emissions, overloads steam traps, creates water hammer, and produces wetter steam. And today we're going to investigate why. I'm Ray Wohlfarth, the Boiler Room Detective. Suppose we have a low pressure steam heating boiler rated at 800,000 BTU input with a 640,000 BTU output. The steam enters a 100-foot long 6-inch steel main covered with 1 inch of insulation. At the end of the main is a drip leg with a 3/4 inch steam trap. As steam travels through the pipe, a small amount naturally condenses into water. That's perfectly normal. The condensate must be removed quickly before it accumulates in the bottom of the pipe. Engineers typically size steam traps at 2 or 3 times the normal running load so they can handle cold startup conditions when the piping is still cool. In our example, the insulated pipe produces only about 5 to 7 pounds of condensate per hour. If we size the steam trap at 3 times the running load, it can handle about 21 pounds per hour during startup. Everything works exactly as designed. Then someone removes the insulation. The pipe begins losing heat much faster. That extra heat causes dramatically more steam to condense. Instead of collecting only 5 to 7 pounds of condensate each hour, the pipe now produces roughly 43 to 49 pounds per hour. Nothing changed about the steam trap. Nothing changed about the boiler. The only thing that changed was the missing insulation. Yet now we are asking that same trap to handle nearly 7 times the condensate it was originally designed for. We've changed the operating conditions. Eventually, condensate begins lying in the bottom of the steam main, and here's where the problem snowballs. That pool of water removes heat from the steam even faster than the pipe wall alone, producing even more condensate. The longer it continues, the worse it gets. Now imagine steam moving through that main at roughly 50 miles per hour. Instead of traveling over a dry pipe, it starts picking up droplets and slugs of water. These slugs become battering rams. They slam into elbows, valves, steam traps, pipe fittings. The loud banging you hear isn't just noise, it's equipment being damaged, and eventually something gives. Another hidden problem? Wet steam. All that condensate creates wetter steam. Imagine sitting around a campfire making s'mores. You hold your marshmallow over the fire and it's roasting perfectly. Then someone throws a bucket of water on their fire. The fire doesn't go out, but before your marshmallow can absorb the heat, the water absorbs a tremendous amount of energy first. The fire is still there, the heat source still exists, but much of its energy is now being used to heat the water instead of your marshmallow. That's very similar to what happens inside a steam system. The water droplets absorb heat that should be available for the heating system. The steam carries less usable energy to the radiators or coils. For every 1% of moisture in the system, you lose roughly 1% of its available latent heat. Now the steam begins condensing before it reaches the farthest points of the building. The distant areas don't heat properly. Meanwhile, the rooms closest to the boiler overheat because the boiler has to run longer to satisfy the thermostat. One missing layer of insulation has now affected the entire heating system. When people see missing pipe insulation, they often think it's only a comfort issue. It just makes the boiler room warmer. But that's only the beginning. Missing insulation increases heat loss, and heat loss creates more condensate. More condensate overloads the steam traps and allows water to remain in the piping. Standing water creates water hammer. Extra condensate creates wetter steam. Wetter steam reduces heating efficiency and fuel consumption. Pipe insulation isn't there simply to keep people from burning themselves. It's there to keep the system operating the way it was designed. Remove the installation and you've changed the system. If you learned something today, please like, subscribe, and share this video. I'll see you on the next case.